3.1, graphing relationships. So we're going to look at graphs. Specifically in this lesson, we're going to look at a couple of different types of graphs. So again, what I'm going to do is I'm going to go to the homework section and do some of these. But before I do that, I'm going to go through here and just point out a couple of things within the lesson itself for you to be aware of. First of all, I want to point out these two terms, continuous and discrete graphs, okay? So what is a continuous graph? A continuous graph is one that just keeps going with no breaks. So all these up here are continuous. You see it just keeps going. It's all connected, okay? A discrete graph is one like this one where there are points, there are breaks in between the values on the graph itself. So that's the difference in a continuous and discrete. Other things we're going to talk about are domain and range. Remember, we've talked about those before. Domain are your X, range are your Y values. So we're going to discuss those in the context of these problems right here. So the first ones I'm going to do are 1 through 4. And the reason I'm doing them in groups is because as you do this homework, you're going to find out that they're kind of clumped together. So 1 through 4 is associated with this graph. It says the graph shows the attendance at a hockey game and the rate at which the fans enter and exit the arena. Okay, so one of the things I want to talk to you about is this word rate, and we'll discuss this later on a little bit more. But rate is nothing more than slope. So I'm going to write the word slope underneath it here. That's not very good. Let's see if I can write that a little bit more clearly. Slope. Okay. So rate is slope. So when we look at the slope, remember if something is going up, it's positive. If it's going down, it's negative. So it says compare segments 1 and 2. What do they represent? Okay. So 1 right here represents the rate at which fans enter and exit the arena. Well, because it's going up, that means fans are entering the arena. Okay. The same thing at 2. They're entering the arena. The difference is in 1, they are entering faster than at 2. Now, how do I know they're entering faster? That entering doesn't look very good, but how do I know they're entering faster? Well, because at 1, the slope is much steeper. Okay, at 2, you see how it flattens out a little bit. So people are still entering the arena, it's just not as many. It's not going up as fast. Okay, it says, what does segment 8 represent in terms of the game? Okay, in terms of the game. So let's look at segment 8 here. So segment 8 is right here, and it is going down. That means people are leaving the arena. Now, a lot of people are leaving. So what does that probably mean in terms of the game? In terms of the game, that probably means the game is over. Or, you know, if you think about UT playing Georgia this past year, people left after the first half because the game was essentially over. They were getting killed. So it has something to do with the game being over probably. That's why so many people are leaving so quickly. All right. The next one was the significance of segments 5 and 7. Okay, so if we look at segments 5, here's 5, and 7, those are two flat segments. That means no more people are coming in. Time is still passing, but no more people are coming in. So probably what that means in terms of the game, it doesn't say this, but that probably is when the game has started and people are just staying to watch the game. But in terms of this question, what's the significance of segments 5 and 7? No more people are coming or leaving the game. Okay. All right. What does segment 6 mean? Where's segment 6? Okay. Segment 6 right here is just a little short one going down. Okay. A little short one going down right here. So what does that mean? Well, that means a few people are leaving. Now, why would that be the case? I don't know, maybe it was intermission. So maybe 5 here represents the first half of the game. 7 represents the second half of the game. So 6 is, people leaving at halftime or something, but a few people leave. Okay, let's go to another one. Let's go to, I'm going to go on the page. We're going to go 9 through 11 here, 9 through 11. So these, we have to use all these graphs up here, A through D. It says, during the winter, the amount of water that flows down a river remains at a low constant. Okay, what's constant mean? Constant means it is not changing. Okay, so that's an important word. Constant, not changing, a low constant. In the spring, when the snow melts, the flow of water increases drastically. Well, that makes sense. If the snow melts, it turns to water. Everything is going to flow much more rapidly until it decreases to a steady, there's another important word, steady rate, which means it kind of stays the same. The flow then slowly decreases through the fall into the winter, so then it slows down. Okay, so one thing you want to look at is what your axis represents. These are very, very important. So here we're representing the seasons, winter through fall, and the y-axis representing the water, okay, the number of gallons per second it says. All right, so number 9, which graph best represents the situation described up here? Okay, so let's think about this again. So let's start at the beginning. It says water that flows down a river remains at a low constant. That means it stays the same, okay? So let's look at these graphs. So what I'm going to do is I'm going to eliminate graphs that don't work. Well, this one doesn't work because at the very beginning it is not staying the same. It's going up. Okay, this one is somewhat constant. Here's the problem though. There is no water flowing, okay? So that one's out because it starts at 0. So right now, the only 2 that kind of work are this one. Kind of stays constant here. This one kind of stays constant. Okay, so we got to see what happens next. In the spring, when the snow melts, the flow of the water increases drastically. Increases. That means it has to go up. Let's look at this one. It stays constant, but what happens? It goes down. This one's constant, but then what happens? It goes up, and it goes up very fast. Okay, so we know it's going to be A. So for question number 9, we know the answer is A. But what we have to do now, let's just follow through and make sure it makes sense to this. So here we are again. It increases drastically until it decreases to a steady rate, stays the same in the summer. Then the flow slowly decreases through the fall into the winter. And then what happens in the winter again? We get a low constant, just like we started. So that graph represents our description, okay? Number 10, describe the other 3 graphs, okay? So if I'm going to describe these, I'm going to write these real quick. So B would be start with no water flow, and it what? Increases continuously. It's always going up. Okay. Let's describe C then. The difference in C is very much like B. However, in C, we would say the same thing. You start with no water flow, and it increases at a constant rate. Okay, constant rate. The reason it's constant is because this is a line. It is going up the same amount all the time. Whereas in B, up here, it's curving, so it's increasing all the time. Okay, D is a little bit more complicated, but we can write it based on how we did kind of with A. So with D, we would say has a low constant at the start, then decreases water flow, then what happens? So we've constant right here, then decrease, then what happens? Then we're constant again. Then returns to a, I'm going to have to move this up a little bit, sorry, lower constant rate. Let me pull it back down so I can see. Then what happens? Then it what? Then decreases drastically or quickly, and then quickly what? Increases because it goes up really fast. So we get right here and we get this decrease and then quickly increase and then returns to a low constant flow. Okay, so we talk about, it says, what are possible situations to represent these? Well, we go to our description. So B says water flow and it increases continuously, goes up really, really fast. So in a situation like that, that might be water over a dam or something. Because you got water flow going constant, but what happens when it goes over the dam? It goes up. The water flow increases quite a bit. C could be the same thing, but C, instead of going over a dam, could be going through a dam. Now, what's the difference? Going through a dam is they maintain how much water is going through it. Okay, going over a dam, the water flow goes very, very rapidly, but going through a dam, they control how much it goes through, so it stays constant, the amount they're releasing. What could happen in D? It could be representing something where you're like in a dry climate, okay? So water flow decreases and then maybe levels out. You get a little bit of rain or something and the water flow levels out, but then it decreases again and you have a hard rain season and it goes up. But a dry climate would be something that represents where water flow decreases pretty consistently. All right. One more here. We're going to do 18 through 20. And here's one where we're actually going to have to graph the answer. Now, they've been very nice to you here in that they have gone ahead and labeled your axis, and that's very, very important. So it says a contestant on a game show is given $100 and is asked 5 questions. The contestant loses $20 for every wrong answer. Okay, so what happens? Well, first of all, we have our x-axis, number of incorrect questions, and then amount of money on the y-axis, okay? So what did we start with? We started with $100. So say that's where we start with. That's where 100 is. That would be at 0 questions. Now, right here, let's say that's 1 question. What happened after 1 question? We lost $20. So what happened? If right here we're at 100, then now we're going to be where? After 1 question, at 80. Okay. Then after 2 questions, we lost another $20. So now where would we be? We'd be somewhere like right here, which is at 60. Then at 3 questions, we would be at 40. At 4 questions, we would be at 20. And then after 5 questions, where would we be at? We would have no money left because we've lost all of it. So we'd have $0. So this is a discrete function. It's based on each question. You can't have a half a question and lose money. So they're just points on the graph. So we've sketched it. Is the graph discrete or continuous? We just said it's discrete. Determine the domain and range. Okay, this is important now. Domain. Domain is our x value. So I'm going to describe the domain using this notation. X. X is less than or equal to. What's the most x can be? 5. What is the least x can be? 0. Now, here's the problem with this description. We're saying every value between 0 and 5. And we can't do that because, what did we just get through saying? You can't have half questions and stuff. Sorry about that, school bell. So, rather than describe it using inequalities, which is what we just finished in Module 2, we're going to say what? Whole numbers. Now, whole numbers say they can't be negative, can't be fractions, can't be or decimals. So whole numbers from 0 to 5. Okay. Now, what about our range? Our y values, what do they go from? Well, they go from 0 up to 100. But again, you can't have partial values in there. So the way you describe that would be multiples of 20 from 0 to what? 100. Now, why multiples of 20? Because that's how much we were losing each time. Not only that, it describes our slope for this. If this were a line, our slope here would be a negative 20 because it's losing, okay? So these are all important terms to pay attention to and follow.